those as I go around and check homework as well. I'll send you photos of your grading quizzes probably, hopefully today. Which was 3, 4, 2, 4, 7. Good job showing work. Where's your work?
That is. What is that one? Number 4?
Number 4. That's the one that I helped you with.
Forgetting we're behind on pages.
Sorry, what?
So I keep forgetting that we're behind compared to other classes on the pages.
Yeah, we move a little bit slower, but then at different points of the year we start jumping forward like 5 or 6 pages because of how our plot diagrams work. Wait, what?
I'll have to store it.
Okay.
Right,
Then where? Oh, there's 7. Is this?
Yeah, that was.
You gotta show me work. So I'm gonna give you a green slip for now, but show me work so I can help you.
But number 7 was.
Should be more math. You help them out. You just need to show me what you did. So show me what you did. And I'll take it away. But you gotta show work so I can help you out. Particularly once we start talking about percent composition, you know what you did wrong. We'll help you out for it. Alright, so let's go over the 3 and 4 from this chapter, and then we'll go back and we'll talk about from the previous section chapters where that's kind of more of a review part for it. Alright, so number 3, classify each of the following as combination, decomposition, single displacement, or double displacement. Alright, what you got, Christopher? Letter A.
Combination.
Combination, perfect. Alright, Ethan, what you got for letter B?
For which number?
B, for 3.
Single displacement?
Is it?
Double displacement?
Double displacement, because you can see how the calcium is taking the H. Now the H is changing its version a little bit. And you have the carbon is taking H's, and the calcium is I'm looking at 2 and 1. And calcium is taking hydroxide at that point. So it's basically splitting apart the water molecule into 2 different parts, so that way they can trade partners. Alright, anyone have any questions about why that one is a double displacement? Alright, letter C, what do you got, Chris?
Single.
That's a single displacement. And the letter D, Ethan, what do you got for that one?
Decomposition.
Decomposition, perfect. Alright, number 4, how many moles of carbon dioxide are needed to produce, I moved my chalk for it, what?
We did this one study already.
In study hall, but remember, Jamie and Quentin cannot see that I helped you in study hall, so they asked for help on Friday, Jamie and Quentin, because they got stuck. So we helped them on Friday, but gentlemen, you should be able to help explain it now, since I've already helped you on Friday, so you can hopefully know what you're doing for it. Alright, so if you're starting with moles of carbon dioxide, it's asking you how many moles of carbon dioxide are needed to produce 3.17 moles of carbon monoxide from a synthesis reaction. Hopefully you copied this down. So if it's a synthesis reaction or a combination reaction, how would you come up with this? Ethan. So if I'm making carbon monoxide, what are the 2 parts to carbon monoxide?
The 2 parts.
Of carbon monoxide. It's Monday.
That is.
Okay, let's give him a minute.
What are the 2 parts?
2 parts to carbon monoxide.
Oxygen and carbonate.
What?
Carbon.
Carbon. Alright, can carbon exist by itself?
Yes.
Can oxygen exist by itself?
No.
So, alright, balance it. We'll let you balance
Put
it
it
now.
in front of the C and the CO.
Good job. Now it's balanced. So this is a synthesis reaction, first off for this one. So now it says how many moles of carbon dioxide are needed if I'm starting with 1.7 moles of carbon monoxide. So it says, okay, let's say that I'm going to have a reaction where I'm making 3.17 or 3.17 moles of carbon monoxide. How many moles of dioxygen do I need? So what am I starting off with? What do I know? Ethan. What is something that I'm starting off with?
3.17.
Good job. So 3.17 is and then what substance is that? Look at your story problem. So it's
Moles.
3 moles of
Carbon monoxide.
carbon monoxide. So moles of carbon monoxide. This is where I'm starting. I'm trying to figure out this. Alright, so if it's moles of carbon monoxide in the top, what goes in the bottom?
I put 2 mol /CO.
Good job. So 2 moles monoxide, because remember, you gotta have your units cancel out. So there's 2 moles in this balanced equation, so it's 2. What's the coefficient of the oxygen?
2.
Coefficient is 2?
1.
1, so it's an understood 1. So since I'm going to moles of this substance, I can stop after this, because it's moles of dioxygen. So 3.17 times 1, or you can skip that, just divide by 2, gives you what, Ethan?
6134.
Say it one more time.
6134.
You multiply, it's divide.
That's what I got too. I think that's what we did on Friday.
Make sure you copy it down correctly then. Alright, so 3.17 times 1 divided by 2. divided times 1 divided by 2.
1.95.
Good job. So 1.5 what?
Nice.
8.5.
Good job. Alright, so if we start off with what?
8.5.
0.585.
Mm-hmm.
Alright, so if I start off, how many figs did I start off with though?
3.
How many should I end up with? We don't worry about the mole
No,
ratios
three.
because they don't count.
3.
So how do I fix
get rid
this?
of, get rid of the make it 1.5 fine.
Good job. So we would need 1.59 moles, I ran out of room, of dioxygen. Alright, anyone have any questions about how to do that? Alright, so now let's go over and work those other problems to kind of help you get ready for your test on Wednesday. So you had 2, 4, and 7. Alright, so number 2, name the following compounds. They basically, for this one, kind of mixed them up as well, as opposed to just a binary molecule, and then with naming an ion, so they put them together. Alright, so that first one, CuI, what is that substance? Ethan, what you got?
For this again?
This is 2A.
Copper iodide.
Alright, is there multiple versions of copper though?
Dicopper iodide.
Alright,
Copper 2 iodide.
so it's...
Copper 1 iodide.
Alright, so how many does iodine normally take?
1.
1. How many does copper give?
1.
1, so this must be...
Copper 1 iodide.
Good job. Copper, 1, iodide. So this one,
I
that's
know how
why...
many uses for it, that's why I said 2.
Yeah, that's probably the reason why you gotta know, okay, that there's multiple versions of copper, so you gotta know how many does iodide take, so that way you can know, okay, which one is this copper then. Alright, letter B.
Zinc 2 chloride.
I think you jumped down to C. B.
Iron oxide.
Alright, there's multiple versions of iron.
Yeah, but it's only one iron oxide.
Alright, but remember, you don't name it based off the numbers of irons if you're looking at the cations and anions.
Mono iron oxide.
Nope, you're naming it like a binary molecular molecule because these are cations and anions. You gotta name them based on their charges. So oxygen takes how many?
2.
Iron gives up how many then?
2.
2. So this is
2 iron oxide.
okay.
Iron
Iron is
2
2
oxide.
oxide, but yes, you have the right idea. Alright, so remember that's the reason why your book points out between a metal and a non-metal, you gotta name them as a cations and anions because they're giving or exchanging charges. We kind of talked through that, the reasons why, but just make a note that if they can exist as an ion form, you want to name them as the ions. Now, if it is a non-metal and a non-metal, like F and G, those are non-metals. So because of those, you're going to name them like a binary molecule. Alright, letter C, Ethan.
Zinc chloride?
Good job. Do you have to give a prefix with it though, because there's 2 of them?
No.
No, you don't. So just zinc chlorate is correct. Alright, so PCl5. So these are 2 non-metals, so how would you name them?
Phosphate tetrachloride.
Alright,
No,
so
phosphate, is it pentachloride?
pentachloride. Now, do you have to change the first one if you're just naming just a substance? So that one's just phosphorus, because that's the name of the element, phosphorus, pentachloride. Okay, number E, Ethan.
Carbon.
Alright, it's Ca, so what's Ca?
Ca is calcium.
Calcium. And then, I'm going to put it in parentheses, oh, it's put in parentheses anyway. Alright, remember what the substance is, what this anion is?
Hydrogen carbonate.
Good job. So, the name for this one is, what'd you say? Partly right, I just want to make sure.
Hydrogen carbonate. Dihydrogen carbonate.
Nope, you're right the first
Hydrogen-
time.
okay,
So hydrogen
okay.
carbonate, or the other name for it is bicarbonate, so either one works for it. So hydrogen carbonate or bicarbonate, so altogether, what will be the whole name for the whole substance?
Calcium bicarbonate.
Good job. Alright, letter F. Alright, Chris.
I put chlorine, but it's tetrachlorine. Tetrachlorine.
Okay, you're flipping them. So it's CI4. What's the substance? Just slow down.
I thought that was
Oh, I did that
I thought that
too.
was CL.
Oh, okay. So that's probably the
CL.
reason. Nope. It's CI. That's probably the reason why the first letter is always capitalized and the second letter is not. So CL, you're right. It's chloride. But this is CI. And I'm sorry. Sometimes they look really confusing. So this is CI. So what's this first substance then?
I don't see the
Carbon.
difference.
You can see how
It
there's
is
little
chlorine.
bitty dots, like little bitty lines coming off the I. In letter F, there's little bitty lines coming off the top and bottom.
There's not.
There's not.
For F.
Oh.
Oh, in my book they put it in Times New Roman. Oh, I'm sorry, they did not.
Yeah, that's
That's
what I put.
weird. Alright, well it's supposed to be CI, so your book has a typo then, so I'm sorry, because they're supposed to have the two dots at the top like it is in the court. Alright, so if it is CI, which is what it's supposed to be, so for this one, it'll be what?
Carbon tetraiodine.
Say it one more time.
Carbon tetraiodine.
Tetraiodine.
Iodide. So carbon tetraiodide. You're right that if it was just before chlorine model, it would just be tetrachloride at that point. So I'm sorry, you look at the typo. That's unfortunate. Alright, anyone have any questions though about F? So carbon tetraiodide is what it wants for that one. Alright, last year they had a different typo, so at least your book's getting closer. Alright, so PBr3, what is that substance? F. I mean for Ethan, letter G. I said F by accident.
Phosphorus bromide.
Close. Now, these are two non-metals. So,
Bromate.
close.
Phosphorus tribromide.
Good job. That's it. That's perfect. Alright, anyone have any questions about that particular section?
Wait, it's phosphorus. I have PB, capital B, or capital P, capital B.
Yeah,
Alright.
it's capital
Oh,
B.
Yeah,
okay.
I was like,
I
it's
see, I see.
phosphorus. It's
Yeah,
phosphorus.
I see.
I know. You just gotta know which ones are which. Alright, it's okay. Alright, letter F. I'm sorry. I'm mixing up letters and numbers. Number 4.
I'm about to say, alright, well.
A. Alright, so you're now writing up the formulas of the following compounds. Alright, aluminum dihydrogen phosphate. You're going to have to describe this one to me. Alright, Ethan's turn.
I just did it. I just did it right. I just did
You
number.
just did phosphorus tribromide, so it's your turn.
Oh, okay.
Okay. Like, tell me what you got.
No, I did phosphorus, and then he said, "What's?"
You helped him fix it, but he really.
I did it.
Oh, you did do it.
I
Didn't
did
he
it.
fix it? Okay. Chris's turn then.
I put AlH2PO3.
H2PO3, just like this?
Yes.
Alright, super close. So, because aluminum wants to give off how many?
2, 3.
3. How many does the dihydrogen phosphate typically take?
1,
1. So how many do I need to balance out the fact that this one is chucking off 3?
3.
3. So that perfect.
Nice.
Why didn't know your charge? Okay, super close. But you almost got it. Alright, sulfur difluoride. So an easy one, hopefully. Alright, Ethan, what you got for letter B?
S.
Okay?
F2.
What was it?
F2.
Final answer?
Yes.
Yes, you are correct. That is the answer for it. Alright, I keep saying number. Letter 3. Alright, Chris, what you got for that one?
KSO3.
Okay.
Oh, I got the hard
Did
one.
you say SO3?
Mm-hmm.
Alright, so it's phosphate. So which one is that?
Ooh, hard.
What?
It's sulfate.
It's potassium sulfate.
So sulfate. So how many O's does it have?
4.
4. Alright, now,
No.
how many does potassium normally give off?
2. No. 4. 1.
1. So remember, it's in group 1, so potassium normally checks off 1. How many does sulfate normally take?
3. 2.
2. So, this one takes 2. So how many potassiums do I have to balance out?
2.
2. That's the reason why you gotta know your charges. So like I said, you don't have to know your charges for the quiz, but you gotta know them because for your test for Wednesday, that way you can figure out which ones
We have a
need
test.
them. Test Wednesday. Alright. You have acetate. I'm gonna have to shift over for this one.
Oh, Mg. It gets off too, right?
It does.
Alright, and then C2H3O2, H3,
Thank you.
and then O2.
Down here?
Yes,
Why?
because magnesium gives off two, and
Oh.
aluminum gives off one.
Good job, that's perfect. Alright, so I don't have any questions though about this one, because that is correct. Alright, iron 3 chloride. Alright, Chris, what did I write for that one?
FeCl.
FeCl, that's it?
That's all I had.
Alright, iron 3
I
chloride.
put Fe at the top of the iron. I put a 3.
Like that?
Yeah.
Okay, so you're partially right. But what does that mean if you have plus 3?
So the charge it gives off.
Okay, so how many does chlorine take though?
2, 1,
1. So how many
3,
chlorine?
4.
Good job. So you don't have to have the charges, but if it helps you to remember, that's great. So that means though that chlorine has to be 3 of them to take each one, because you can't just yeet them all. Chlorine can only take one at a time. Alright, lead 2 sulfide.
BB.
Okay.
Two. Okay.
Like that?
No, it gives off two. I'm
Good job.
pretty sure. And then, sulfide is adenine.
Alright. So how many does sulfur?
S2.
Down here?
Yes.
Sure.
Yes.
How many does sulfur typically take?
1, 3, 4, 7, 2.
2. So if sulfur takes 2 and
That's
lead,
good right there.
is it? You're done. You're done. So you don't have to write the charges, but just make it just lead sulfide. Alright. Last one, a little bit of an easier one, guys. Dinitrogen monoxide. What is that?
H2O.
Did you say H?
What?
I know N2O.
Okay. N2O. Yes, that is correct. Alright, anyone have any questions about that? How to do that? Alright, number 7. Now keep in mind you have a whole section on your test on that. So just make sure that if you have questions, we need to go over it, over how to do it. Alright, number 7 now. Calculate the molar mass of the following substances. So iron 2 oxide, and then I believe it gave it to you what it looks like, so that's helpful. So, because of that, how do you find molar mass? I think they also asked me this on Friday, Jamie and Quentin, so that's something good. You might have a little bit faster for this one. So what do I use to find molar mass?
Don't you grab them together?
Alright, and then where do you, like, what are you looking at when you combine them together? How do you, like, what are you combining?
Your answers.
Alright, so let's walk through this one. So this first one is iron oxide. I think it's just iron 2 oxide. So FeO. Alright, so what am I combining? What are you looking at to figure out? What am I combining?
Iron to 55.85 plus 16.
Alright, where are you getting the 55.85? It doesn't
That's
tell
the
you that.
mass number. That's the atomic number. No, it's the, what is it called?
You mean
The mass number?
you
The
mean
molar number? Mole number? What's it called?
You mean the molecular mass? Like how
Yes.
much it weighs? Okay, yes. Where are you getting it from? What tool are you looking
Periodic
at?
chart. of
Yes, so
elements.
periodic table, so that tells you how much they weigh in atomic mass units. Now we're finding it in molar mass, so we'll talk about units in a second. But you already you add them together. Add them together, what do you get?
71.5.
Good job. Alright, how many sig figs?
4.
What? 4.
4. And then now are we doing addition, subtraction, multiplication, or division?
Addition.
Addition, subtraction, so do I go off number or do I go off place?
Place.
Alright, so E. And then where does this one go to? Does it go to here or does it go to here?
It has to.
It has
So it goes
it
to
has
16.
whoa, it goes here?
Yes.
Why do these not count?
Because they do count.
They do count because there is a decimal point and they're to the right. So these count. So
I already have 4 sig figs, so you're done.
yep, so it rounds to the 100th spot because both of these end in the 100th spot. Now this is molar mass. What units do I put on? Because molecular mass
MOL.
you're very close. MOL. You're missing one thing.
G.
G, this is
Oh,
grams
okay.
per mole. So that's the difference between molar mass and atomic and the molecular mass is simply just the unit. It's the exact same process, but it's just the units. Alright, look at the next one. Hydrogen peroxide. Alright, what do you have for your answer, Chris? Let's go ahead and just jump in.
34.016. That's
Alright.
how it should be. It should be 34.02.
I copied it down wrong, I'm sorry. So 0.16, and you're right that it should convert to this part. Alright, and then what's your units?
Grams mole.
Grams per mole. Good job. Alright, Ethan, do you have for letter C then?
352.
Just 352?
Yes, but it's not proper sig figs, is it?
Oh,
So
alright.
it's 352.00.
Ooh, okay, so uranium looks like this on the periodic table, and then fluoride is fluorine.
352.0. There.
Yes, and then what's your units?
Grams per mole.
Grams per mole. Alright, so keep in mind, because this one ends in the tenths, that's why this one has to end in the tenths. Alright, letter D, calcium carbonate. Alright, what do you got, Chris?
216.87 grams per mole.
Alright, let's go to, is that what you got as well, Ethan, or did you get something different? What'd you
That's
get?
something different.
What'd you get?
116.09.
Alright, let's double check this then. Alright, what's the weight of calcium? You have all calcium over here, so can you also see me? Okay. What's calcium's weight?
40.08.
40.08. Alright, what's carbon's weight?
12.01.
Good job. I lost my spot. 12.01. Alright, what's oxygen's weight?
16.0.
But how many oxygens do I have?
That's 3, so multiply by 3.
So I think maybe that's where some of you ran up
I
on,
did
is that
it.
it's
I did
multiplied
that,
3
for sure.
times something. So it's the 40.08 plus the 12.01 plus the 3 times 16. Now add it all together, and that should help you out for it. I think you might have just multiplied yours, Chris, like 3 times everything. That's what it sounds like you did. That's why I need to see math, so I can help you figure out where you went wrong.
No.
100.0.
Point zero, what was it?
09.
09, and then, okay, so now let's look at sig figs for it. Alright, so where does the sig figs end in this one? Ethan, let you start first. You can barely see me in the video.
4.
4? Oh, there's 4 sig
Oh, I
figs.
have 100.09.
Alright, so
I
where does
added that wrong then, because I had 116.0.
yeah, it sounds like you had like an extra oxygen in there somehow. Alright, so where does the sig figs end in the carbons? Where does it end at?
4.
Alright, so, and then 4, the oxygens, where does it end at?
4.
Alright, so it ends at the 100th spot.
So you're good.
So just like this?
Yes.
Yeah, because it's still
Grams per
in the
mole.
100th spot. So you might think, wait, what?
Grams per mole.
Yep, so you might think, well, wait a second, these only have 4 sig figs each. Nope, because remember, for digit structure, you go off the place. So even though it feels weird that there's 5 sig figs technically, it still ends in the 100th spot. Alright, anyone have any questions about that? Alright, let's look at your quiz really quick. We can't go over the answers, but look at the quiz really quick. I can't show you the answers, so Jamie and Quentin, you'll have to just look at your own quiz for it. This is a good practice to kind of see what are the different types of reactions. So, number 1, not going over the answer, but just looking at it, it has hydrogen and oxygen together to make one substance. So, what type of reaction is that, Chris? For number 1, you have hydrogen combined with oxygen.
Is it a combination?
That is combination. Alright, let's look at number 2 then. Can't go over the answers, but just looking over it. So you have zinc kicking off hydrogen and taking its spot. So what type of reaction is that?
Single.
That's single displacement. Number 3, you have oxygen combined with iron, making a new substance. What type of reaction is that?
Combination.
That's combination again. Ethan, back to you. What do you call that one when you have carbon monoxide and nitrogen monoxide? What was that?
Single displacement.
Yep, because basically oxygen is being stolen, so poor nitrogen is being left on its own. Alright, last one. You start with one substance. Well, sorry, not last one. Number 5. You start with one substance and you break apart into 2 substances. What type? Decomposition. And then number 6, you have, I believe that is, I don't remember what that one is. So that's pentane, I believe, plus oxygen. And so pentane is giving up part of its hydrogen, taking an oxygen, and oxygen is splitting apart basically into different parts of it. So what type of reaction is that? Kind of a trick you're going to see.
It's just double displacement.
That's double displacement. Alright, anyone have any questions about which type of reaction is which?
Double is and single is when I get mixed up.
Single is, you look for single, the easiest way to tell for single is that, I'm good, that's just my trajectory. If you see a substance by itself, and you see that there is 2 other substances, whenever you look at the other side, if A has taken the spot of one of them and has kicked off the other one, that's how you tell for it. So typically, double is whenever you have the ions.
Can you write it like now? Like ABC?
I'm just reading off my space. So it would be like, for example, I'm just gonna make one up. Let's say you have potassium fluoride and, nope, that's gonna be hard in a minute. Oh, what's another ion? Sodium. Sodium chloride. They would probably not react to this, but we'll just say this in hypothetical situation. That, let's say they break apart and they reform up as this. That, okay, so for our number sentence, you have cation A, and then you have the anion B, cation C, anion D. So you can see now, okay, K is A over here, fluorine is B, sodium is C over here,
That
Chlorine.
double displacement.
is D. So it's double spin. So basically, they have traded partners. So it's
So if you have like 4 substances, then that could be that could possibly be double displacement.
it's a good sign that it's double. Doesn't mean
And if
all the
there's 3,
time.
it's single displacement. Most
Typically, if you have zinc, we'll just do it like this because that's an easy one. But if you see it like, technically this isn't balanced anymore, but it's okay. So you have zinc to where one of them is by themselves, and they kick off one of them to take its spot. That's single displacement. So the typical rule of thumb is if you're looking for one substance and you can see that it has now taken the spot of one of the other substances, that's single displacement, where it's getting kicked off by itself.
I was about to add, you forgot the G and
I think I wrote.
it's
Oh,
just-
you're right.
Yeah, you're right.
Gonna make it look
Alright.
okay, otherwise it'll bother me. Alright, so just to fix it, so it's B, C,
So the top one is single?
Top one's
Is
double.
it? Because both of them swap partners.
Oh, no, never mind,
So
sorry.
this is double, this is single. Alright, you don't have any questions, guys? Do you have any questions about how to tell you? What can I do this up here? Alright, you gentlemen are far enough apart to where you don't need a cover sheet, but make sure you have a working pen out. Jamie, you can go ahead and get out your quiz as well. I sent it to your mom on Friday, so hopefully she printed it out for you already. If not, go ask her for it really quick. And Quentin, I sent it to both of you. Here you go.
Oh no.
Here you go. Alright, so, oops. Alright, really quick, look at the A, B, C, and D section, because your book put them in alphabetical order as opposed to how we learn them order. So A is combination, B is decomposition, C is double displacement, D is single displacement. So sometimes students are not paying attention and they just do it as how the order we've done. So pay attention, C is double and D is single. So pay attention to what you're doing. So all you're doing is just matching them up. The answers maybe used more than once, one time or not at all for obvious reasons.
Is it okay if I write AB over my A?
Sure, go for it, yes. I would actually recommend writing A over the cation and anion sections, dividing them up so you can easily see it. You don't have to, but I'll recommend that.
much time do I have?
I can give you about 3 more minutes still, because sometimes it takes a little bit longer.
Examination cover. How much time do I have?
Give you about another maybe minute, maybe 2 minutes tops. Well, we got through some of it already, like the naming ions and stuff like that's a major section of chapter 4. So we've already kind of partially reviewed going over all that. And molar mass, that's part of chapter 4. So we got like a 20-minute review already in today. Alright, need more time, Ethan? Alright, you can go ahead and pass it to me, and once you do that, go ahead and take a textbook over to page 58. That's the last thing we gotta talk about before your test. So last little bit of math, we got through most of it on Friday, talking about mole-to-mole ratios. So now we're talking about mass relationships and chemical reactions. This one's also kind of like a review for you, Chris, because we have to go back to talking about molar ratios and then molar mass. So it's kind of like two ideas combined together to get you ready for your exam. Alright, so your book points out, and we've already talked about this, for using a substance to figure out, okay, how much of a substance, what's the mole-to-mole ratios in a balanced equation, and to figure out, okay, if I start with so many grams of substance, how much can I get from it? So what's the substance and the, what do we call something that you're going to run out of it first? Like what do you call it whenever you're going to run out of an ingredient? Limiting reaction. So your book gives you an example. Your book tells you how to solve it on page 58. So if you were to mark those 4 steps as we go through them, because it's easier to see an example as we go through it. So your book points out, determine how many grams of oxygen are needed to completely burn 75.0 grams of propane fuel according to the following reaction. So we have propane, so C3H8 plus 5 moles of oxygen, CO3, 3O2 plus H2O. Alright, so your book already gave you the balance equation for it on your test. I'll give it to you with the balance equation if I'm doing this. So I won't check it as combined like this. But it's the idea of, okay, in some cases you might have to just write all right up in a balanced equation. Not right now for it, so we're not going to worry about it. Alright, so now it says, determine how many grams of oxygen are needed to completely burn 75 grams of propane. Alright, what am I starting off with? What is the information I am given? Ethan. If I'm starting off with 75.0 grams of propane, what is the first sentence? Page 58.
Okay, 58.
Alright, so what sentence am I starting off with? If I have 75.0 grams of something.
So what element?
What compound?
C3H8.
Yep. So C3H8 or propane. Now what am I looking for? Where am I going?
What do you mean?
Like,
Grams.
according to the story problem, it says determine or figure out how many grams of
Oxygen.
oxygen. So what am I looking for?
Oxygen.
Oxygen. So I'm going from propane to oxygen. Figure, okay, how much, if I have this much of this substance, how many of this substance do I need to burn it all off?
5.
So that's what you're, wait, no, this is 5 moles, but how many grams do I need for it? Alright, so for this one, I'm starting off with 75 grams of it. Do I know how many moles that I have of this substance right now if I'm given 20 grams? We can't figure it out. If I'm given 20 grams, and how many moles I have? How do I do that? What do I do?
Times C3 by 12.01.
Oh, I'm sorry, that's an H with an H.
That's a C.
Oh, I know what you're doing, but so you're going ahead and putting it in contrast units. So 12.01 times
3.
3, and then there's 8 hydrogens, and how much is hydrogen one?
1.00.
There you go. Add them up together, and what do you get?
36.03 and then 8 point and then 8.0
6.4.
yeah, 64.
You have a calculator? I mean, you could, but you have a calculator.
Uh, 37.094.
Double check that, because it's 3 times 12, so that's at least 36, plus 8 times 1.008.
44.09.
There you go. So 44.094. We'll leave it unrounded for right now. Alright, so this is the grams in 1 mole of this is propane, is that what it says? Propane. So so where does this number go then? If this is the grams of
75.
what?
Under 75.
Right here?
Yeah, because you can divide, if you divide it, you get that more.
You put it on the other
You
side.
can, but yeah, typically you put it down here so we can work with the ratios as we go across. But you're right that you put it in the bottom. So 44.094 grams, that'll give me 1 mole of
So you define it.
propane.
and
Wait. Yep, we're not putting that in. Because this gives me moles now. But I have to do a mole to mole ratio. So this is the moles of this substance. According to this balanced equation, how many moles do I need of this substance?
1.
1. Okay, so it's 1 mole. How many moles of oxygen do I get from this balanced
5.
equation? Because I have to use the balanced equation to figure out how many moles I'm going to end up with. 5. Alright, now we're not quite done. Show up my room.
What?
Yeah, because this will only give me the moles. But it's asking me how many grams of oxygen. I'm going to shift these down so I have more space. Alright, so if I started off with 5 moles of this substance, what can I use to figure out if I'm going from moles to grams? What can I use?
The weight of it too.
Yep, so to figure out table again. So 1 mole, this is part of the reason why you want to keep your units. So you can keep track of what goes in the top and what goes in the bottom. So 1 mole of this substance equals how much?
32. 16.
I think they did actually want 32. Good job. 32, because there's 2 of them for it. Alright, and that'll give it to me in grams. That's part of the reason why you want to keep your units straight, because it makes it easier to set it up as you're going across. So, this one combines molar mass and mole ratios at the same time for it to be able to see, okay, I started with grams, so I gotta convert to moles, gotta use mole ratio, then gotta convert back to grams. So that's part of the reason why you work it out this way. So go ahead and plug it all in so you can see what your answer is.
I got 12,000.
It sounds like, okay, so it says 75.0 divided by 44.094 times 5. I'm leaving off the multiplier divided by 1.
It's 214.4291274.
Try it one more time because it sounds like you're getting off somehow.
Times 5, then divide by 1, and then times by 32.
You take the 75 and you divide it by
44.094 times 5 times 32.
I got
You don't-
272.
There you go.
46.
272 point what?
146.
146. That's the answer for it. So just be careful because it sounds like you might be getting a mistype somewhere. So 75 divided by 44.094 times 5 times 32. I left off all of the multiplied divided by 1. If you do that, it won't hurt anything. Alright, so is that the answer you got, Ethan, now?
Oh, I'm good now. Yeah.
Okay, good. Alright, now I started off with 75.0 grams. So how many sig figs is that? Good job. 3. Now, since you're multiplying and dividing, do I go off number or do I go off place?
Place. Number.
Number. So if this is 3 sig figs, how many sig figs does this one have? 3. How do I fix it?
272.
Good job. Grams of dioxygen. Alright. Anyone have any questions about how to solve something like this? It's not hard if you know what you're doing, but you gotta know what you're doing. That's what it's talking about in those 4 steps. So write a balanced equation, convert the mass amount to moles, use a mole ratio, convert the moles back to mass. So it's 2 different ideas combined together. So anyone have any questions about how to solve this? Because you're gonna have a homework question and it may potentially be on the test and I can't tell you yet. Does anyone have any questions about how to solve it? Alright, so we just still do have time for a review on top of everything. Alright, so go ahead and take out a piece of paper so you can write down terms and definitions you don't know. We've done kind of like a random day of doing reviews on top of learning new information.
So we get our homework for the review.
Yeah, that's probably right. Alright, so your homework for tonight. Ed, you're gonna have a practice problem with this. So if you get stuck, you can either ask me in study hall, if you want to cheat if you're a gentleman here, or you can ask me tomorrow, but make sure you're getting practice for it. So you're going to do on page 59, number 5, and so you're going to have 2 sections for it. You're going to do on the top section, the 4.3 review, you're going to do number 4.
Wait, what?
So there's 2 different review sections.
Page
So
59?
page 59. Again. Alright, so 4.3 review, number 4. And then in the bottom section, the 59, there you're going to do number 5. You're also going to do
What are we doing on 4.3 review?
4.3, number 4. You've already done 1 through 3, so you should recognize it. Oh, I've already done this. So number 4 in the 4.3, and then number 5 in the problem section. And then also, okay, so problem number 2, A through C. So I'm giving you a little bit of, I'm breaking it apart for you, but you have to write the balanced equation, and they're giving it to you in the ion form, so that way you have to write them out.
What page?
That's also on page 59. So page 59, in the chapter review section, number 2, A through C. So you're balancing the equations, but you have to write them out. So if you get stuck, come ask me in study hall so I can help you out, but you gotta know your ions. Alright, so now, reviewing and thinking back over it.
More on review for a geometry.
What?
Said more on review for a geometry.
I'm sorry, I can't do that one, I can't help. Alright, so we're going to do, I think I have the PowerPoint for the ships. It will take too long to load, so we'll just do just the dicing really quick for it then. Alright, go ahead and load points in the next, like, 40 minutes.
Yeah.
Alright, take one. Sure, show math in your homework. Alright, so what do you call the numerical relationship between elements and compounds? What do you call that branch of science?
Stoichiometry.
Good job, roll. Alright, what do you call a type of formula that tells how many of each type of atom are found in the actual molecule of that substance?
Chemical formula.
Alright, there's a more specific word than that.
What start with?
M. How many?
Molecular formula?
Good job, molecular formula. Alright, what is it that shows the smallest ratio in a molecule?
So,
E. What type of formula is that?
Imperial formula?
Close enough, empirical formula. What's the other name for the empirical formula if you're talking about an ion? Because they're
Ionic.
always given in the simplest versions.
Ionic formula?
Not ionic
Let's
formula,
start
F.
And F?
And F. We have a special name for them. They don't have the word formula in it though. It's another name for the empirical formula. It's referring to an ionic compound in particular. Alright, formula unit. Write it down. Formula unit. Alright, there's no one new. Back to Ethan. Alright, Ethan, if you're going to name a binary molecule, so don't have space. So let's say you have a binary molecule like, oh, it probably wouldn't exist like this, but we'll just say it does. Alright, like this. How would you name it?
Just name it.
Okay, how?
What do you mean how?
Okay, say the name for this
Oh,
substance.
carbon tetrafluoride.
Good job. So the first one, you just say the name. The last one, you give the prefix and you change it to I. Alright, anyone have any questions about how to do that? Because that is something you need to know for your test, and how to name a binary molecular molecule. Moving on then. Alright. We'll go over hopefully the names of the cations and anions on Monday, but let's say you have a substance like this, where it's the ions. How would you name this substance?
Copper 1 iodide.
Alright, so how many does iodide take?
2, 1,
1, and so there's 2 of them, so the total charge is -2, so how many does copper have to give?
2.
2, so how would you say the name?
Copper iodide. Copper diiodide.
Okay, you're putting the prefixes in front of it. So instead of using a prefix with the ions, what do we say, or what do we use?
Copper 1 iodide.
Okay, so it's given off 2.
Yeah. Copper 2 iodide.
There you go, copper. So if you were to write it out, you would write it out with the Roman numerals, but you would say it as copper 2 iodide because it's giving off 2 electrons. Anyone have any questions about how to name an ion compound? Remember, you name them based on the charges, not on prefixes. You have questions about it?
Can you repeat this?
You don't have to keep it anymore. Alright, do you have questions about anything? You look kind of confused. Chris, you have a question about it? Okay, moving on then. So what's the sum of all the molecular masses of all the atoms in the formula of a compound? What do you call just the weight of an entire compound altogether?
Starts,
Starts with an M.
mass number.
It's not just mass. Mass number refers to the number of protons and neutrons together. It's the mass of the entire molecule.
Molecular mass.
Molecular mass. What is Avogadro's number?
6.022 times 10⁻⁵.
Good job. Yeah. What's the unit we use to refer to Avogadro's number? Instead of saying I have Avogadro's number of something,
What number is it?
like what unit? Like what's the
Mole.
unit? Good job. So we know that. Alright, so if I'm trying to find the mass per mole of a substance, what is that?
Grams per mole.
Wait, grams per mole, number first 2.
Molar number.
Molar mass. Alright, roll. Alright, who has 15 or more? Alright. Who has 25 or more?
I have 24. I have 30.
Okay, either one, don't forget your candy. I'm trying to email if you have any questions.
Homework? Oh,
Alright, David.
yeah.